Hello, I promised I'd be back another time to look at question 6b of the IEB November 2023 paper 1, and that some other time has arrived. So welcome to a nostalgic math chat. We will be rambling about some finance. Cool. Disclaimer I gave in my first finance video is that, and I think it's a disclaimer I've given before just in general, that I really like to live lean when it comes to formulas and what formula to use to approach this question. And if the question's like this, then you use this formula. Oh my goodness, I can't live like that. So I do tend to take then a longer scenic route with questions, especially in finance. So if you are comfy with the formulas, do the formulas, but if you're like me and you just want to have the smallest toolbox possible for your exam, then follow along for this question. Let's see how it goes. So question 6b, let's go. To start your ice cream business, you take out a loan for 250,000 rands. The bank offers an interest rate of 10% per annum compounded monthly. Wow, that is so sweet of the bank. Hectic. Okay, maybe not so sweet, but like, that's a really cool loan. How much should you pay each month if you would like to pay the loan off at the end of 10 years? If the first payment is made at the end of the first month, give you answer correct to 2 decimal places. Okay, so with loans, there's something interesting happening, right? So on the one hand, you have this loan of 250,000 rand, which is going to accumulate or accrue interest at the rate we've been told about here, right? For 10 years. So that's the first thing that I calculate is, okay, what is the value of the loan, interest included? So that would be 250,000 times 1 plus 0,1 divided by 12, and it's going to grow for 10 years, and there's 12 months in each of those years. Okay, so I'm just going to work out what that number is and store it on my calculator. So 250k, 1 plus 0.1 over 12, and 10 times 12. Okay, so 67660,372 blah 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 blah. Okay, just gonna quickly store that in A. Okay, and I'm just gonna make a little note to myself that I've stored this number in A. Capital A. Right. Okay, so that's how much I'm gonna need to pay overall with my repayments. So now we need to figure out, okay, how much do those repayments need to be in order to cover the loan and the interest that it will accrue. So to do that, I first want to imagine, okay, this is the timeline. At T0 is where you took out the loan, right? Okay, and at T1, at the end of the first month, is where you need to start making repayments. So you're going to repay some amount X. T2, you're going to repay some amount X, and likewise T3, you're going to repay some amount X. And so it's going to go until T120, right? Because this is a 10-year loan, 120 months, and that is when you will make your last repayment X. So now the interesting thing with the repayments is that it's almost like you make your repayment and it gets to also accrue interest for however much time is left in the term of the loan. So for instance, this first X over here, right, is, you can kind of imagine it as it's going to go into a different account and kind of sit and earn interest at the same rate as this. Okay, and the question then becomes, okay, so how much is this repayment worth at the end of the term of the loan. Whatever interest that is accumulated also then goes towards paying off the loan. So what we end up with is a geometric pattern. Right, let us write this down. So we're going to have your first x, and actually, you know, this actually works better if you just do it in reverse. In the previous video, I was stubborn. I did it in the order of T1, T2, T3 because that's just what was instinctive, but then it became messy. So let's try it in reverse, right? So I'm just going to fill in a couple more periods here. Okay, right, so the last repayment won't earn any okay, the value of the repayments, this was the value of the loan. Okay, just to distinguish. Anyway, okay, so the last one won't earn any interest. It will just be x, whatever x is, and then your loan account will close. The one before that will get to earn interest for a month. Oof, not 0.2, 10% over 12, right? So for 1 month, it will get to stew in the account and earn a bit of interest. The one before that, so this guy, will get to earn interest for 2 months. And the one before that will get to earn interest for 3 months, right? And so it will go until, you know, we get this very first one, right? And how many months is it going to earn interest for? It's going to earn interest for 119 months. Okay. Right. So as we can see, as I prophesied, this is going to give us a geometric, this is in fact a geometric series, right? So this is a geometric series where A is x, r, okay, we are timesing by 1 plus 0,1 over 12 each time, right? So here we started with just x, and then we times with one of these, and then we times with another of them to get 2 of them now, then we times again with it to get 3 of them now, right? So each time we're timesing by 1 plus 0,1 over 12. Okay, right? And then lastly, n, the number of terms is 120 of them. There are 120 repayments, and you can try and calculate the geometric series in reverse, right? If this had been your first term, then your r would be this to the -1, because for each subsequent term we have one less of the 1 plus 0,1 over 12, right? And then your a would be this guy. That would be your first term, and your n will still be 120. If you did it that way, you will still get the same result. So it's just a matter of simplifying life for ourselves. Okay, so we are now expressing this sum using our geometric series formula that says that, right, it's a times r to the n minus 1 over r minus 1, right? So our a is x. Okay, maybe I gave way too much space. Our r is 1 plus, okay, I did not give enough space. Okay, 1 plus 0,1 over 12 to the power of n, which is 120. Okay, and then we also replace r down here, so that will be 1 plus 0,1 over 12. Okay, and if we simplify that some more, in fact, what we can do is just figure out what is the value of this, right? So essentially, what is the coefficient of x? So I'm going to get my calculator out for that. Okay, so that is a fraction, first of all. And then second of all, we have 1 plus 0.1 divided by 12 to the power of 120 minus 1. And then again at the bottom, 1 plus 0.1 over 12 minus 1. Okay, so I'm going to store that inside B. Okay, and mental note that I am storing it. Well, okay, wait, let me not do that yet. Let's just first write the next line here. So this is going to be 204,84 ... times x. Okay, so this number over here I'm going to put inside B. I already did. Okay, so smart. Okay, right. So we know that at the end of 10 years, the value of our repayments will have become 204,84 whatever times whatever the repayment actually is, the month-to-month number, the month-to-month amount you're paying towards the loan. So what we want is for this amount, the value of the repayments, to equal the full value of the loan. So we need to figure out the x that will make the value of the repayments equal to the whole value of the loan. So this is the equation we're going to solve. I'm going to need u. Oh, not the y. Let's see if I can avoid it. Okay, so okay. And we need u. Okay, so we need these two to be equal. So easy equation to solve, right? X is just going to be this number divided by this number. Okay, and let us see what we get. So my first number divided by my second number. Okay, and that gives us, I'm just going to write it here, 3, well, I could just move the calculator. Okay, so that gives us, to 2 decimal places, 3,303,77. And like I said in my previous video, someone who understands the formulas probably did this in like 3 seconds. So up to you what you want to invest in. Do you want to invest in understanding the formula, the specific context you use the formula in, or if you want to be a caveman like me and go back to the very fundamentals, the very basics behind the formula, then this is the approach you can follow. And with enough practice, then this kind of a thing goes quickly. Anyway, so that's the first part of the question. Let me just check if the memo agrees, or if I'm just misleading the children of gold. That would suck. Okay, yeah, we both get 3,303 and 77 cents, which is fantastic. Right, so now, same question, part B. If you decide to pay 6,000 Rand per month, only starting at the end of the second month, then how many payments will be needed to pay off the loan? You must round up to the nearest number of payments. Okay, so now the timeline looks a bit different. So we took out the loan at T0, and then only at T2 do do we start now paying back 6,000 Rand per month? Okay, and we want to know, well, when will be the last 6K payment required? Right, so again, pretty much same logic, okay? We know that the value of our loan, interest included and all of that, we still have that here, right? That is 676,760,372 blah 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 blah, right? And we want our repayments to match that value, also including the interest that they accrue, right? So again, we would have to think about, I'm going to do it in pink again. So our repayments, and I'm going to start from the end again because that one doesn't accrue any interest, so that's a nice first term. And the one before that, so at t n minus 1 will be 6,000 as well, and t n minus 2 will be 6,000 as well, and so on, right? So that one will only earn interest for a month. The one before that will earn interest for 2 months. Right, and so we go, and so we go. Then we have to figure out, okay, well, this very first 6K, how many months will it earn interest for? So it's going to earn for 1 month, 2 months. Essentially, it will earn interest for n minus 2 months, right? So if the loan is active for n months and for 2 months we didn't put in any money, that means that the 6K will only then earn interest for n minus 2 months. Okay, so if n was 10 months, right, this 6K would only earn interest for 8 of those months. Okay, oopsie. Okay, cool. So this is again a geometric series, right, pretty much similar to before. Okay, A is 6,000, R is, we are timesing by that each term, right? And then the number of terms, is how many terms are there? So that would be n minus 1 here. Yep. Oh, it's weird to use n and n and choose different letters. Let's call it K. Okay, so that would be K minus 1. Why is it K minus 1? So again, let's imagine if it was 10, if it's going to be 10, not 10 repayments. Let's not confuse language. If the duration of the loan is somehow 10 months, so TK is T10, right? Then the number of payments that have been made is 10 minus 2 plus 1. Okay, I'm making this unnecessarily complicated. Okay, so if we did make a payment over here, then we would have made a total of K payments. But because we didn't make a payment here, then it's K minus 1. Yeah, okay, I think that's a better explanation, hopefully. Okay, so we can now then use our geometric series formula. Okay, so our A is 6,000, Okay, our r is 1 plus 0, 1 over 12. Our n is k minus 1, and then our r again, you write down 1 plus 0, 1 over 12. Okay, and now we've got an unknown over here, so we can't simplify this expression quite as nicely as we were able to before. So let's see what we can do. This will be, let's just write it as 6,000 multiplied out. 1 plus 0, 1 over 12 to the power of k minus 1, and then multiply with the 1 as well. And then the bottom, we have 1 minus 1, so those two cancel out. And then we're just left with 0, 1 over 12. Okay, and then as with the previous question, right, we need, where's my pointy thingy? Oh, there it is. We need the value of the repayments, okay, to equal the value of the loan with its interest. Okay, so we are pretty much solving a similar equation, except we're dealing with a different unknown. Okay, so, oopsie. Can I copy you? Thank you. Right, so this needs to be equal to this. Okay, I'll just move everything lower. It's fine. Okay, so now we need to do some fun maths. Okay, so first I'm gonna get rid of this guy by timesing both sides with that fraction. So we've got 6, 7, 6, 7, 6, 0, 3, 7, 2, dot, 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 times, oops, so very enthusiastic times, times 0, 1 over 12, and that has to be equal to 6,000 times 1 plus 0, 1, 12 to the k minus 1 minus 6,000. Okay, so let's see what we get here. Use the unrounded number, peeps. Okay, wait, alpha, okay, times 0.1 divided by 12. Okay, so that gives us 5,639,669. Okay, so I'm just going to try to keep that in memory now. Okay, so now we add 6,000 to both sides to get rid of this guy. Okay, so if we do that, plus 6,000. All right, then we get 11,639, 669, blah, blah, blah. And that will be equal to 6,000 times 1 plus 0, 1 over 12. So k minus 1. Okay, so next obstacle to get rid of is that 6,000. So we're going to do that by dividing both sides by 6,000. Okay, so divide by 6,000, and that will give us 1,939 blah blah blah, and then we have 1 plus 0, 1 over 12 to the k minus 1. Okay, so now we have an exponential equation which we can solve using logs, right? So remember, the relationship between logs and exponential equations is if a to the x is equal to b, what we are then saying is log base a of b is equal to x. So essentially if my base is A, what power do I need to raise it to in order to get B? Okay, so let's just put that as a side note. Okay, I think this is the last time I'm using pink because it's just so vibrant. Wow. Okay, so let's rewrite this equation as a log question, right? So my base is 1 plus 0, 1 over 12, right? And what I want to get is 1,939 warawa, right? And the exponent will have to be k minus 1. Okay, so if we can figure out what this is, right, then we can figure out what k is. One last thing, let's get rid of this guy by adding 1 on both sides. So k is equal to, yeah, not writing that again, sorry. K is equal to that plus 1. Okay, so calcs come to the rescue. Okay, so I'm just going to clear this. Do I still have, yes, I still have my desired answer. So log, oh, okay, I was about to die. Right, so log, the base is 1 plus 0.1 over 12, and the desired outcome is that guy, okay, and then we're going to add 1, right? So the answer there is, well, and we're told to round up. Okay, so that will be 81 months, or 81 repayments, right? What is the question? The question was, how many payments are needed? Okay, so that is 81 payments. Right? Yes? No? We do not agree? The aura, the aura, the aura, the aura of it all, the aura, the aura, the aura. So this is the part where I go over my workings to see what went wrong. What went wrong? Okay, so first of all, okay, so this is still the same from the previous question, and the memo and I agree about that. Let's just check that I do in fact still have the right number. Right, awesome. Okay, so then the question is, I need my repayments to come to the same value. Okay, paying 6,000 Rand per month, only starting at the end of month 2. We don't know how many months we're going to, or how many payments that's going to take. Also, I'm just realizing something as well. K is counting the months, it's not counting the repayments. So the number of repayments would be K minus 1 actually. So this is the number of payments, not K. Not bad. Okay, so it completely wasn't necessary to do this part of getting rid of the poor little one. Okay, but even so, this just takes us to 80 months instead, well, 80 payments instead of 81. Right? What? Am I speaking nonsense? Yes, I think so. Okay, but we'll get back there. Right, so we have your last payment not accruing any interest, the one before that accrues interest for a month, the one before that accrues interest for 2 months, and then the very first payment, how long does that accrue interest for? It will accrue interest for this duration, okay, which is k minus 2 months, because all of these make up k months, and for 2 of those months it's not earning interest, so it will earn interest for k minus 2 months. Okay, so I still stand by that. Right, so then we have a geometric series where a is the first term is 6,000, r is 1 plus 0, 1 over 12, and n, the number of payments, is k minus 1. Yes, because again, if we had started paying at T1, then we would have made k payments, but because we're only starting at T2, then we're making one less, so k minus 1 payments. Okay, right, so a times r to the n minus 1, and then over r minus 1. Okay, so then we times the 6,000 in, and we get that term minus 6,000, and over here this simplifies to 0, 1 over 12. Cool. Then we said we want the loan amount, well, the repayments, to add up to the loan amount, the total loan amount. Okay, so then we times both sides by 0, 1 over 12 to get rid of this guy. So let's just see what that gave us. Times 0.1 over 12. Okay, so that gave us that number. Okay, right, and then next up we wanted to get rid of this guy, so we added 6,000 on both sides. So add 6,000 on both sides, which gives us this number. Okay, then next we wanted to get rid of this guy, and we did that by dividing both sides by 6,000. Yeah, yep. Okay, so take the answer and divide by 6,000, and that gives us this number. Okay, so now we then re-expressed this equation as a logarithm problem. Okay, so we said we need to, this is the base, this is the outcome we want, what is the power we need? So I'm actually going to take this and store it inside C. Okay, then I'm going to say 1 plus 0.1 divided by 12, which gives me 1, okay, I'm going to store that inside D. Okay, so we need log base D, and over here we need C. Okay, and that gives us 79,850, etc., etc., which is 80 payments. So I am arriving at the same point that I departed from. My goodness. Care to explain yourself, memo? All the memo is giving me is a formula that I don't know, that I don't understand. Oh my goodness. Okay, sorry, I understand my mistake. Okay, so it is not this number we are after because the loan term will of course be different. It's not 10 years. Okay, it's not necessarily 10 years. It'll be different because we're repaying a different amount. And so, in actual fact, most likely the term will be shorter because we're paying more, even though we're starting late. We're not starting that much later. So, do not just casually bring information from the past in. Girl, come on. So, our loan is 200. Oopsie. Okay, so our loan is 250,000 Rand. Okay, and it is going to grow at 10% per annum, compounded monthly, right? And it's going to grow for the full duration of the term. We don't know how long the term is. That's what we're trying to figure out. So there are K months in the term. That much we know. Okay, so I'm just going to make that a bit easier to rewrite everywhere. Ooh, what a momish. Oh, I can't even do that because, guys, oh, man, I am making my life so weird, right? Because of this exponent. So I can't just times these two and say it's, right? It's only this part that's to the power of k, not this part. Okay, right. Not on a good roll, hey? Not on a good roll at all. Okay, so this equation changes. Oh, my hard work. The agony. Okay, I'm done lamenting my life. Can I delete you, please? Thank you. And you. Let's pretend that never happened. No, we're not going to pretend it never happened. Mistakes are good. We like mistakes. Okay, right. And if you had spotted it from early on, well done. Jeez, man. Okay, so we want the repayments to add up to this amount, whatever this amount is, right? The loan and all the interest that it will have accrued. Okay, after K months. Okay, so this becomes quite an interesting equation to solve. Let's see if we can do it. So again, we're going to start by timesing both sides. Times by 0,1 over 12. Okay, so then we've got 250,000 times that guy times that guy. Okay, and on this side, we're just left with 6,000. 1 plus 0,1 over 12 to the k minus 1 minus 6,000. Okay, so I'm going to simplify this. Okay, so that is 2083,3, right, times by that. Let's just see if I can get away with keeping it in memory. Okay, next up, let us add 6,000 on both sides to get rid of that guy. Okay, so that'll just be this. Okay, and then here we're just left with this. Okay, right, and then last obstacle, I mean, yeah, what is it worth? Okay, yeah, let's do it. Last obstacle is this guy, so let's divide by 6,000 on both sides. Yeah, I mean, I say obstacle, knowing fully well that we have an unknown on this side too. So are we not just moving the problems from one side to another? Okay, so if we divide, actually, it's a shorter way we can write this. But for the sake of seeing things through, let us see this through. Okay. So let's see, calculator. So that is, well, okay, we could write this as, it looks nice as a common fraction for once. Okay, and 6,000 divided by 6,000 is 1. Okay, and on this side we've got 1 plus 0, 1. Okay, right. So this is an exponential equation, right? What you want to do is you want to get all these unknown guys, get those terms on one side, and this guy must skedaddle to the other side. So we've got 25 over 72. Right, and this guy comes to this side, that one becomes a negative. Okay, and this term we can write split up, right? So I am not writing this again, oh my goodness. Okay, so we can write that as 1 plus 0, 1 over 12 times k to the k. What am I even saying? And then 1 plus 0, 1 over 12 to the negative 1, right? And we do that to highlight that these two terms have a common factor. This guy is common to both of them. So now instead of having k in two separate terms, we can use factorizing to just have it show up once, right? So now we've got that. Okay, so this is what remained from the first term, and this is what remained from the second term. Okay, so that's that, and that is this one. Okay, and so now remember, weird as this looks, this is just a number. There are no unknowns over here, so we can punch this into a calculator, okay, and figure out what the value of that expression is. Right, so that is 1 plus 0, 1 over 12 to the power of k, and over here we have negative 0, 644 blah blah blah, right, is equal to 1. Okay, so we want this by itself, so what shall we do? We shall divide both sides by negative 0, 644 blah blah. Yo, when did this lose its minus? Okay, same over here. Okay, and so now what we are left with is 1 plus 0, 1 over 12 to the k is equal to, we're going to say, negative 1 divided by that number, which gives us 1, 5, 5, 1, wara wara wara. Okay, and so this is a log. We can express this as a log, right? So k is equal to log, where the base is that, and the amount we want is 1, 551 blah blah. Okay, and what does this give us? Right, this gives us 52,93 la 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 la. Okay, so now we need to go back to the question, right? The question says how many payments will be needed. Okay, K is not the number of payments. Remember, K is the length of the term. What? The term of the loan. Yeah? Okay, and the number of payments is K minus 1, as we saw over here. Okay, so N, i.e. the number of payments required, is K minus 1, which is going to be 52,93 blah blah minus 1, okay, which is 51,93 blah blah. Then we had to round up, right? So that is 52 payments required. My laptop just died, but I did see previously that the answer was in fact 52. Okay, wow, this was such a long journey, but I hope worthwhile. And in going into the mistakes and everything, I would say, yeah, the moral of the story is, hey, just think carefully, hey. And I think there's a good thing with making mistakes is it kind of sensitizes you for things to look out for, little ahas that could trip you up in the exam. Yeah, catch you for another chat later.